This will be a lecture on the ecological footprint, what goes into it, why it's useful, and kind of some of the special components of it that really make it necessary for us to evaluate where the human population is relative to what we might consider its carrying capacity. So one of the things to remember in all of this is when we talk about non-human species, we can define that carrying capacity as the maximum population size the environment can support indefinitely. But when we actually look at a population of non-human species, imagine like each of these dots represents an individual here on the right, and we count them up, and that becomes our population size that we are then evaluating in comparison to what the environment can support. There's a basic assumption in this that tends to be valid, is that all individuals are equal in terms of their overall impact on the environment. And remember, because the carrying capacity is determined by the environment, that impact of the individual on the environment is what is really critical there in determining how many individuals can be supported by that environment. Now, what if, however, that assumption is not valid? And this is really where the issue is with the human population, is if you look at the human population, you'll have some individuals in different populations that have a relatively small impact, but then others that have a very, very large impact, depending on where they live, the resources they use, the pollution they generate, and the overall impact on the environment. So you can't simply just count up number of individuals and assume they're all equal and then use that number to determine carrying capacity. And so that's where the ecological footprint comes in. And what you basically have here is we'll look at a population. You can do it at the level of an individual, but you can also do it at the level of a population. And you start to look at kind of key components, things like energy, the settlement, how much space they need, the houses we build, the amount of timber and paper that we use, the food and fiber that we use, the seafood that we consume. And all of that then can be looked at from the standpoint of how much of a carbon footprint an individual population has, the impacts of that built up land from that individual or the population, the impacts on forests, on croplands and pastures, and on fisheries. And we translate that into this footprint that then we can compare against what's available for the human population to determine really where we are. So here's kind of another way to look at it, is rather than look at it as individuals, as a person here, where instead we're converting that person into this area. And that area is what's required to produce the resources and to assimilate the waste for that individual's lifestyle. And this area here is, in essence, the footprint. That's the footprint of that person or that population on the planet or on the environment that is required to maintain that individual or that population's lifestyle. Now, if we were to look at that, again, if you look at this from the standpoint of a population growth curve down here below, where, you might call that red line K for carrying capacity, it's a little different now. It's not really just a number of individuals, but now we consider the carrying capacity what we basically have as what's available on our planet. So think of it as like one Earth. And if you add up all these footprints of all the populations of humans on the planet, if that is, basically less than one Earth, then we're below the carrying capacity. If it's equal to one Earth, then we're at carrying capacity. And if it's above one Earth, then we are in overshoot. So instead of just counting up numbers of individuals, we convert those individuals, we convert those populations into area. Then we compare it to what's available on the planet in terms of things like amount of arable land, amount of productive fisheries, amount of forests, all the things that we are using for our resources, and all the area that's needed to assimilate our waste, we can then get a sense of where are we in terms of this carrying capacity in a kind of a slightly different way than we would for non-human species. Now, the reality is the data show we're actually above. So the data show that the most recent data we have is we're at 1.75 Earths in terms of our current global footprint of the human population. And a question you might have is, how exactly can we be at a footprint larger than the planet? And so there's a little different way of looking at this. A couple of different ways I'll show you. Imagine that you've got $100,000 as an initial investment. This is gifted to you. And you have an interest rate of, let's say, 10%. And so if this is for your $100,000 and you have this 10% interest rate, that means you basically get $10,000 every year that you can live off of. So that's what this represents, the $10,000. And you can see that if you got that interest rate year after year after year, you could live off $10,000 a year forever. However, you could, let me just change colors here. You could spend more than $10,000. I mean, you could spend $17,500 as an example. Maybe you want to buy a bigger car. Maybe you want to eat out more often. Maybe you want a larger house, for example. It's possible because the money is there. It's in your account. But what you're doing is you're no longer living off the interest. Now you're dipping into, right? You're dipping into this principal, the original investment. Now you can do this for a while, but of course the inevitable scenario is that this expenditure basically drives down your principal, your initial $100,000 down to zero, right? You're going to end up with nothing at the end of that because you're going to basically drain that account. So what this basically shows is you can live beyond your means, if you will, for a certain period of time. And what does it mean in this case for our bank account to basically be going to zero? You know, what was this initial $100,000? And what we want to look at here is basically this is the arable land. Soils that were rich, that were able to grow food and able to grow native vegetation. These are our forests. These are our fisheries. These are things like a stable climate. This was the $100,000 investment we got from the planet when we became a species, if you will. And so what does it look like for us to be draining our account? It's to be turning arable land into desert. It's to be, cutting down our forests. It's to be overfishing our fish stocks. It's to be pumping greenhouse gases into our atmosphere and creating greater climate instability. So all of those components are indicators that we are basically living beyond our means and driving our account, that what we inherited, if you will, to zero. One of the challenges we face in all this is at any given time, it's challenging because if you were to just look at an individual and you're going to say, okay, well, at any given point, the person that's spending at this level looks like they have a better life than the person that's spending at this level. They have a better car, they're eating out at, fine restaurants, they have a larger house. And so if you don't look at the actual account balance, if you will, and you're only looking at these two measures, then it looks like it's better to be spending beyond your means. So you have to account for all of these components here to determine whether or not what we're actually using in our environment, our resources, what we're contributing as waste, those have to be considered in addition to what we tend to think of as, our economy, our economic growth, our gross domestic product, our, stocks and bonds and things like that. That's only one component. That's this component here. We have to also consider these two components to determine whether or not we're actually spending or actually living in a sustainable way. So what does it actually look like? What are the components of this footprint? And what you've got here is down at the bottom, you have the key for each one of these. You can actually see in some cases, most of these have stayed either relatively stable or have increased a little bit, slightly. Things like built up land have gone up. You can see that you also have cropland has increased. One of the benefits with cropland is if we've increased efficiency and yield per acre, then we can get more food out of the same amount of land. So some of that is kind of attenuated there. But where you really see the big difference, of course, is in this component here, which is the carbon. And so you've probably heard of this aspect called the carbon footprint. And sometimes people will talk about that specifically, and that's what this is here. This big blue area here that's been going up, that's the carbon footprint. And you can see there is really one of the main drivers of this increase in our global ecological footprint that's driven us past what's sustainable. Remember, here's our number of Earths of 1. You can see where we crossed it, probably right around 1970 is probably where we crossed that threshold and started to go into overshoot. So anything above 1 here is overshoot for the human population, and that has primarily been driven by this increase in our carbon footprint. And it's not uniform around the planet as well. So if you look at countries, and I just picked out a few, there's a lot of different examples, you can see that, and again, this is the ecological footprint, but it's global hectares per person. So this is accounting for per individual. So obviously a larger country will have more people, and so the overall footprint will be larger. For example, China in here has a relatively small ecological footprint per person, but if you expand that out for a country, their footprint is going to be very large, because they have 1.25 billion people with that footprint. But if we want to look at how individuals live in a given country and how that contributes, you can do this per person evaluation. And you can see here's the U.S., Canada, Australia, just some other countries that you'd be familiar with in terms of their lifestyles. And you can see that they're quite high. Not the highest. You can see here Qatar, which has a very large ecological footprint. And again, from this graph, you can see what dominates it, right? There's the carbon. So you're looking at a lot of energy use, for example, in a country like Qatar. But look at, what these kind of wealthy countries have in terms of footprints per person, compared to the less wealthy, Nigeria, Bangladesh, Pakistan. And again, that really illustrates that difference between, what we were talking about before when we were saying that humans really violate that assumption that each individual has the same impact, right? Here's your big human impact over here, and here's your little human impact over here, showing that discrepancy and really kind of showing also that difference between, if you might call it, the haves and the have-nots. High wealth over on, to the left over here, and kind of the poorer countries towards the right. Another way to look at it is to look at it by region. And so again, here's the U.S. just as comparison, and North America is going to be very similar because it's going to be dominated largely by the U.S. Canada is going to contribute a certain amount to that, but the U.S. really kind of dominates there. And, you can see this kind of discrepancy. One of the key ones to really look at is North America and U.S. versus Europe, because you really do have a very similar quality of life, yet you have a quality of life here in Europe that has a much lower global hectares per person. So Europe has achieved a similar quality of life education, economic growth as the U.S., but with a much lower ecological footprint. Again, there's the world as a comparison. And you can see, again, down into Africa. And when you're seeing this, too, this is that not only do they have a lower ecological footprint, but chances are you're also seeing a lower quality of life, lower life expectancy, higher death rate, the various components that put Africa a little bit earlier in that demographic transition that we've talked about before. But again, I'll refer back again to Europe. And there's also, of course, individual countries within some of these areas. For example, Costa Rica has a very high quality of life, very high life expectancy, and they have an ecological footprint about 1/3 of that of the U.S. So you don't need to have a very high ecological footprint to have a high quality of life. But those of us in the U.S. and some other countries really do push that footprint up. And again, you're seeing a lot of that associated with this carbon footprint component here in blue. Another way to look at how this works is something that's now called overshoot day. And what that basically means is, rather than looking at it as like a savings account, but to look at it as a rate of use. And so one way to think about this is what we use in a given calendar year, can that be replenished in a given calendar year? So if we use it in a year, can it be replenished in the same amount of time? If we're using a year's worth of resources and creating a year's worth of waste before the year is up, then we're not living sustainably. So the best way to kind of be sustainable on this system is to be as close to January 1st as your overshoot day. And you can see, some regions are pretty close. There's, December 18th for Indonesia. Ecuador, is in December. Cuba is over here in December, just some countries you might be familiar with. But look, again, here's Qatar, way over here in February. So what that's saying is, by February 11th in a given year, Qatar has used its ecological biocapacity for that entire year in less than 2 months. And so the whole remainder of the year for Qatar is dipping into its reserves, is dipping into its savings, if you will. Here's the U.S., again in there, March. So we have a long way to go if we're actually going to try to bring ourselves all the way around, so that by the time a year is up, we've only used 1 year's worth of resources and created 1 year's worth of waste. And so there's a kind of an effort, if you will, to kind of move the date, kind of move that overshoot day later and later into the year. Now, another aspect of this is to look at a particular country and this kind of combination of population growth and ecological footprint. So one of the things you can see with population growth in here is China has been increasing in population growth during this time period. But one of the things that's increased even faster than population growth is actually the ecological footprint per person. And when you combine an increasing footprint per person and an increasing number of people, then your overall footprint is going to go up very rapidly. And so the ecological footprint of China has actually gone up 570% from about the 1950s, much faster than just the population growth. Now, what kind of drives this? Again, thinking about that demographic transition, is countries going through that process as they become wealthier, right? You're going to increase the number of cars on the road. People can now afford cars. You're going to increase meat consumption. And, generally wealthier populations move up the food chain, if you will. They go from consuming mostly a plant-based diet to more meat-based diet. You're increasing house sizes. You're increasing, economic consumption. Right? People can now afford to have more things, so they're buying more stuff. And of course, one of the other things that often comes along with this is an increase in energy use, which results in increases in the carbon footprint. Now, keep in mind, none of this is required. It doesn't, as a population goes through the demographic transition, there's nothing that says you have to increase the number of cars on the road, you have to increase your house size, you have to move up the food chain, you have to buy more stuff, and you have to use more energy. But it tends to be the case. It tends to be the trend that has happened in many countries going through the demographic transition. So kind of connecting these two concepts together, not only can we benefit our overall ability to sustain our population into the future by decreasing that birth rate and kind of paralleling it a little bit closer to the death rate as it comes down, but also decreasing the rate of growth of these ecological footprints per individual. If we can, either through technology or exporting kind of behavior and kind of societal patterns, and decrease this increase in the ecological footprint per person, then we have a much greater chance that we can have a higher quality of life and maintain a longer-term sustainability for the entire human population. So fundamentally, this is kind of our choice. I mean, this is where we've been going. This is where we're at. This is the 1.75 Earths that the current human population is at. And we got to decide, are we going to keep going up? Or are we going to turn around and come down? And one of the key aspects here is the further we go up this line, the steeper it gets to get down to a more sustainable level of this kind of, one Earth over here. And, one way to kind of think about that is it's kind of an odd, though somewhat parallel scenario of kind of flattening the curve, if you will. The longer you wait to take action, the greater the challenge, the higher the peak, the harder it is to come down, as opposed to kind of delaying it longer and longer. So if we can just decrease this rate of increase of the footprint, we have a much greater chance of bringing that down to that one Earth, coming back down to what our carrying capacity is. And that's this combination. And again, because it's a footprint, it's a combination of both population size and the ecological footprint per person. So there's a role for both the developing countries, if you will, the ones still going through the demographic transition, to kind of decrease that rapid population growth. But there's also a very significant role of countries that are already in kind of the latter stages to really start to get their ecological footprint under control, decrease it, and then use that knowledge base, use that technology, and export it to these developing countries so that as they move through the transition, they can achieve that same high quality of life without a massive increase in their ecological footprint per person on top of their population growth.